In this video, we want to talk about a paper titled Fine-Grained Visual Prompting, published on June 7th of 2023. And it's an interesting paper, so let's get to it. This is a paper on visual language models. And the motivation of that is that in these models, we have limited performance in instance-level tasks that demand precise localization and recognition. Now, visual prompting is something that was done in the past. However, the existing approaches are suboptimal due to inclusion of irrelevant and noisy pixels. So this work is going to focus on visual prompting to fine-grain those inputs. They study this visual prompting designs by exploring more fine-grained markings such as segmentation masks and different variations of that. They introduce a new zero-shot framework that leverages pixel-level annotations from a generalist segmentation model, which they use as a core component in this work. And then they call their approach fine-grained visual prompting, or FGVP, and show that it has superior zero-shot performance. This is an example of the visual promptings. So you can see that there are coarse promptings. For example, you have crops, you have raw image, you have the blur reverse box mask, meaning that you take basically the content that is more representative here, and then you draw a box around it and you blur the rest. You have the grayscaling and things like that. Now, in the FGVP, the main goal is that rather than drawing circles and things like that, use a generalist segmentation model from the model segment anything, and use that mask and compare contours, masks, grayscale masks, and blur reverse masks, which they showed to be particularly effective. The concept of zero-shot object recognition via visual prompting can be summarized like this. Let's say you have an image of dimensions 3 channels of colors, H and W. You have n box proposals, and you have m captions, each one of them being a textual description, for example, TY to TM. Visual prompting is going to take this I in these box proposals and create these visual prompts for you, for example, by cropping, by blurring the rest, and things like that. And then you want to assess the similarity of each one of these visual prompts and each one of these texts, which can be done by using cosine similarity of models such as CLIP, which are trained jointly to basically represent images and text. In fine-grained visual prompting, what they do is this segment anything model is going to be used here as this generalist model, and they take I and M in order to use the segmentation masks to create this. And this is the paper for the segment anything model. So they take the image, they have this grid-wise key points, they feed it to the segment anything model, they receive the masks associated with each one of the objects. They fine-grained visual prompting is going to create these prompts, these visual prompts, and then they have the text as well. Then they use a visual language model such as CLIP in order to assess the similarities of these things, but this time with these more fine-grained visual prompts. And in a nutshell, they show in the results that this achieves superior zero-shot performance. You can see that this beats the other works in these tasks. For more details on the results and methodology, please refer to the paper, which is linked in the description. And thank you so much for watching this video.